So, welcome to the session Overcoming the Discoverability Crisis as part of the Open Publishing Fest. I'm happy to introduce you to my co-organizers, Girija, Goyal and Joe Akin, co-founders of ReFigure, and Maxi Schramm, who is Open Knowledge Maps board member. My name is Peter Kraker, and I'm the founder and current chairman of Open Knowledge Maps. But we are not the only ones who will contribute to this session today. If we are looking at the agenda, you will see that we have inputs from many important organizations and initiatives in this area. So we're going to talk about discovery practices and workflows with inputs from ReFigure and AfricArxiv. We're also going to take a look at open discovery infrastructures and tools with inputs from OpenAIRE, Content Mine, ReFigure and OKMaps, CyVerse Austria, and Lever Press and Michigan Publishing. And finally, we will also have an open discussion about systemic issues of discoverability, where we're looking for all of your input. But this is not the only time where you can participate. We have set aside time after each presentation, so you can ask questions and share your comments. All right. Before I hand over to the first speaker, I would like to give you a little bit of an introduction to the topic, and I want to start with a definition of discovery, and this one comes from the Triple Project, which is an EU project dedicated to developing a discovery platform for the social sciences and humanities, and I propose that we adopt it as a working definition within this session. And in Triple, we say that with the term discovery, we mean that the capacity to explore, find, access, and reuse material, such as literature, data, projects, and profiles that you would need for your own research work, such as finding relevant papers, which will help with your research, or finding a person you're interested in collaborating with. So I know that probably not everyone will agree with this. I still would say that we move the discussion around this to the last part, to the open discussion, and at this point look at the issue at hand. Why did we gather today? And that is, I think, very well summed up in this picture that was published by Science, or this article that was published by Science 2 weeks ago. And it says that scientists are drowning in COVID-19 papers. Depending on the data source, about 20,000 papers have been published on the topic. And of course, it also depends heavily on how you define coronavirus related research. But what we can see is that there is a torrent of new knowledge that is being created, and that it's doubling at an alarming rate. So I think about 20 days. So, I mean, this is great, and it shows the immediacy and the real need for the research in these times. But on the other hand, it also poses a big problem for researchers in the field, in that they have a trouble in getting an overview of the research, and once they have it, to then keep it. And this is, of course, now very apparent with the COVID-19 papers. But I think that many of us, for a long time, they have actually felt like this person here. We're simply swamped with the literature in all areas. 3 million papers are published each year, conservatively estimated, and that brings a lot of problems for discoverability. And this is in one part expressed in the reusability numbers of scientific knowledge. So we see that we have a high uncitedness of publications between 7 and 63%, depending on the discipline. This gets even worse when we're looking at data sets. So this is a piece of research that I was also involved in, and we found that up to 85% of data sets are never cited. And where it gets really bleak is the transfer to practice, because even in an application-oriented discipline such as medicine, only a small amount of research knowledge is ever transferred to clinical practice, and if so, with a considerable delay. And the situation actually has gotten so worse that a group of researchers around Jonathan Jeschke and the now president of the Austrian Science Fund, Clement Tockner, have coined the term dark knowledge. And dark knowledge now doesn't mean insidious or nefarious knowledge, if there even is such a thing. This refers to public scientific knowledge that cannot be discovered and as a result of that cannot be reused. So we don't see the wood for the trees anymore. And this is extremely alarming, especially since this research group, this research group assumes that there is way more dark knowledge than there is knowledge in the light, and that the share of dark knowledge is actually rising. And this does away with many of the positive effects that we were hoping for with increased accessibility to science and research. So I think we can say that there is a discoverability crisis, and this discoverability crisis, it negatively impacts the quality and the efficiency of science, because if you don't have all of the evidence, well, then the quality of your own research may also take a hit. And if you're constantly repeating knowledge that has already been validated, then that's also very inefficient. And all of this manifests then in these slow transfer to practice times. And as we can see, this lack of discoverability, especially in the current situation, it can cost human lives. So I think we can see this discoverability crisis at the moment from sort of the outside. But what does it actually feel to be part of the current flood of publications? And for that, I would like to ask Girija Goyal, who is a researcher at Harvard University and one of the co-founders of ReFigure, to give us an input from the view of the biomedical researchers. So Girija, please take it away.
Thank you, Peter. I'm just going to try to share my slides now. So let's see if that works as well as it did in the testing. Can you guys see my slides?
Yes, thank you.
All right. So I'm just going to put this in full screen. We're not sure if that's actually helping or not, but let me know if something seems off kilter. So just to introduce myself, I'm a senior research scientist at the Wyss Institute for Biologically Inspired Engineering, which is a research institute at Harvard University, and it's a collaboration with some other universities in the area like MIT and BU. I'm also the co-founder, along with Dr. James Akin, who was going to be speaking later, of ReFigure.org, where we've been thinking about how science is shared and discovered and acted upon for quite a few years. And today I'm speaking wearing both those hats to try to describe my experience as the co-founder of ReFigure, as well as a research scientist during this period of COVID-19 related research coming out. So I started seriously engaging with COVID-19 related research in late January, early February, for both doing research on the bench in my life as a researcher, as well as because we were curating related findings, seminal findings that were coming out from different papers in ReFigure. And so the first question was, where would I get this information? And at the time, most of the information coming out was in a preprint format. And I just took these numbers from Jeff Flyer's article in Stat News, where you can see that very rapidly over the first few weeks, hundreds of articles had been published in a preprint format. And currently, bioRxiv is receiving around 50 articles a day. So what would happen is that I would open bioRxiv and be just faced with this list of articles, all of which were coming sort of sideways. Some hadn't even been formatted properly or proof edited because they were just coming out so fast. Peer-reviewed articles were in a minority at that time in February, although now they still continue to be in a minority, actually, but there are more of them. And one would also hear how, for instance, Boris Johnson acted on a study from Imperial, but if you went to actually find the study, you would find a link in popular news outlets. And when you clicked on it, it would just take you to the Imperial's webpage, which now has hundreds of studies. So it's actually impossible to find the one that they are referring to. So this was the landscape at the time. And as a researcher and as someone trying to curate that information, it was very, very frustrating. So this is just to show you bioRxiv and medRxiv, which is the predominant preprint servers where these articles are being published, although a number of them are also in Elsevier and Springer's preprint servers. And this is what it looks like. There's about 4,000 articles now, a little over 4,000, and there's a list. If I search for something that matters to me, I'm an immunologist. If I search for immunology terms, I might get hundreds of such a list-based thing. And keep in mind that a very small fraction of researchers work on infectious disease, let alone coronaviruses themselves. So many of us who have now started attacking the problem did not have a background in the field. So it was just, we would get this list of papers, and it was really like you start plodding through them, and many of them were not relevant, or data later turned out to be questioned by later findings. There was also a lot of news or buzz around data sets and organizations such as Google, who were trying to use computational approaches to create data sets. While these efforts are commendable, and in fact now they, for CORD-19, this is what this one's called, they actually will give you a sort of AI updated feed every day if that's what you want. Unfortunately, for most biological researchers like me, this is great, but this is not something we can engage with. It's a data set for machines, not for us. So just coming back, just summarizing all of this, the questions were, how do I find actionable research that allows me to formulate a research plan for my laboratory? How do I find which of this research is reproducible and has been reported by multiple groups, given that there are preprints coming from everywhere? If I'm just starting out, what are the key findings that I should keep in mind? And where can I share and comment on what research I think is important, reproducible, or conversely unreliable? How do I keep track of it all? Where can I search for preprints, journal articles, and databases together? And very importantly, one thing we have observed as bench scientists working on COVID-19 is that great ideas are rediscovered by everybody. And so many people have started doing the same things, whereas there are some under addressed aspects of the research which nobody is doing. So then the question is, how can I find collaborators who are working on similar or complementary solutions? I would like to end there and leave a couple of minutes for questions if somebody wants to discuss my experience or add to this from their own experience.
Thank you very much, Girija, for this very interesting presentation. Which really gave us an insight as to how it feels to be part of the research right now. So I'm asking the participants, do you have any questions? Do you have any comments? Please type into the chat or simply speak up by unmuting yourself.
Hello, this is Alessia Bardi from OpenAIRE, and thank you for this presentation. So I'm working for this OpenAIRE initiative, which is about pushing for open access and open science, and we give a lot of value to the preprints, which are often the only version of an article that can be accessible in an open way. So in your presentation, you gave an impression like, in fact, you are confused of so many preprint articles that are available. So what's the balance between opening your research as soon as possible and checking the quality? What do you think about this?
That's a great question. Yeah, and similar to you, we support preprints, and it's great that they're coming out. And a number of researchers I know will put their research out. I think in this current crisis, I myself was flummoxed by finding that because we could put it out and we were we felt this urgency to put research out. Many times, I can speak for the preprints that I'm trying to work off. Their controls were not in place for the preprints. Sometimes there's a lot of formatting and proofreading errors, but that is sort of a minor point given that the science is out. So in the past, the situation was that you would find preprints which were the open record, but you knew that at least it had been peer-reviewed and published. And even if you couldn't access the published, the peer-reviewed record, right? Now the situation is that most of the research is preprint. So I don't have an answer. I totally agree with you that we can't and we shouldn't restrict the access to information, but are there tools out there to validate it and make it actionable?
Thank you very much. There is 2 comments in the chat for you. The first one is interesting mention of machine versus human readable data sets, which is indeed an issue and only feasible for data miners. Do you have any comment to that?
No, in the interest of time, yeah, I mean, I'm glad that there is some agreement around that, although some people might feel differently.
Thank you. Yeah, I think in the interest of time, I'm also gonna read the second comment, but I think we're also going to move it to the tools section that we have later on, because it is a tool like Meta useful for keeping abreast of new articles. It allows filtering on various things that could help reduce the number of documents you need to manually review. So thanks for this comment or this question, and I think we will take it into the tools and infrastructure section. So next up, we have a presentation by Umar Ahmad of University Putra Malaysia and Malaysia Genome Institute, and he's also part of AfricArxiv. And his presentation is entitled Discovering Research Outcomes from and About Africa. So without much further ado, I'm going to make Umar the presenter and we'll ask him to take it away.
Hello everyone, can you hear me? Can you all
Yes,
see
very
my
well.
screen?
Yes.
Yeah, my name is Umar Ahmad I'm actually a Nigerian, currently based in Malaysia, doing PhD with University Putra Malaysia, with collaboration with Malaysian Genome Institute, working on bladder cancer. I am in my 4th year as a PhD student, waiting for my doctoral defense at the moment. I'm also working in collaboration with Science Communications Hope Nigeria and African Science Literacy Network, trying to support African researchers, trying to dispel the misconceptions around science communications and science research in African countries, and Nigeria particularly, using Science Communication Hub. And I serve as a bioinformatics coordinator in the Science Communication Hub Nigeria, where we support our local African scientists in Nigeria to show them the basic bioinformatics tools and some of the programming languages that they need to know about bioinformatics. I just want to walk through with you on AfricArxiv. Is basically the same as bioRxiv and other repositories around. They are basically server that hosts complete scientific manuscripts available online freely for scientists to access them before the peer review by the journals. And there are lots of benefits attached to this preprints, or if you are a scientist, to deposit your paper in a preprint server like AfricArxiv. And these benefits will be publicly available, so that means you'll be exposed to many scientists around, and likely you get collaborators around, and you get highly cited before even your papers be reviewed by the journals, and then you get credits and you get feedback from scholars around, so you'll be able to improve your contents of the manuscripts before it become published by the journals. In the one thing I forgot to tell you regarding the AfricArxiv is in AfricArxiv we do accept not only scientific manuscripts, we also do accept data sets, presentation slides, or student reports, conferences, conference proceedings, as well as FOSTA. You can deposit them and they will all get a DOI assigned to it. So you'll be exposed and people will know you by your presentations, by your research, by your data sets that you deposited to the AfricArxiv. What we basically do with AfricArxiv, what we want to do, our basic missions and ambitions, is actually to promote the use of local African languages in sciences and then bridge the gap, the language barrier within the African countries, continent, and then increase the discoverability of African researchers as well. So that because there are local scientists around Africa that find it hard to get their article published in the top journals, but using AfricArxiv, which is freely available, they can be able to deposit their work and they can be known, they can be discovered around the world, and likely they will get collaborators around the world as well, and within the country, within the continents of Africa. And as well, it will showcase African scientists based on their field to the global community of scientists. Here is our team, actually, that spreads around Africa, across Africa. We work as a team to support the open access, the position of scientific papers in AfricArxiv. And here we have some of our advisors, the governing boards, the AfricArxiv, and we have some of our collaborators or partners, such as Open Publishing, Science Opens, and then Zenodo, as well as Open Science Framework. And we collaborate at the moment because we are currently working towards owning our own repository that will help African scientists to have free user open access and then open source, and a repository that will be hosted by African territories and will be owned by African science community. But at the moment, we are collaborating or partnering with these open source repositories. Here is just to show how African scientists can get easily recognized, very visible to the world by merely depositing their articles to the AfricArxiv, and the paper will get downloaded, and it will be, and scientists across Africa will be able to discover who that scientist is, and you'll be famous, you'll be exposed more. That makes your work to be visible and downloadable to many other scientists. As you can see, this paper is actually one of our paper that we sometimes we deposited in 2018, and now it got around 435 downloads from around the world. So by developing the research discovery portals in Africa, African scientists can be able to scholarly communicate at ease, and then find a means to identify collaborators within the continent and as well in the global stage, as well as it will be very visible to the global community of scientists with their research output. So here, together with Open Science, we are curating automated collections of COVID-19 research articles that are specifically dealing with challenges and achievements on African continent, which are curated by our AfricArxiv teams. But it's basically a text-based. There is no data set or anything of that nature. It's just a text-based papers that are found around Africa. And here we just made a basic searching using the terms COVID-19 and Africa to find out how many deposited documents we can find in open knowledge maps, which you can see we have around 77 documents with 63 that are open access. Also, we made search of COVID-19 and Africa within open knowledge, which we have 77, and by archive we have 73 documents. Science often we have 76 documents. This is to say that there are lots of researches on COVID-19 in Africa, but due to lack of journals, most of the journals in Africa, they are not actually online, and some of them, even you Google them, you cannot find them unless if they provided you with a link that you can basically search and use the link and find out about the journal. So most of their papers are not recognized within the search engines that you can be able to find. But we believe there are a lot of researches on COVID-19 within Africa, but they are invisible to find out due to this issue of journal communications, which are mostly, they printed it as a hard copy, not online. Most of them, many of the local journals and regional journals are printed in a hard copy format, not in a digitalized way like the other journals around the world are doing. So with this, I end my presentations. I thank the participants. Maybe if you have any questions, you can answer. Thank you.
Thank you, Umar. That was very interesting. There is a comment in the chat that says, "Congratulations for setting up AfricArxiv." This is a sentiment that I can only share, and it's great to see how it's growing and how the collaboration around it is growing. And I actually have a question myself, which is essentially a comment that came from the Sabta Erwin Irawan. Many of you will know him from Bandung Institute of Technology in Indonesia and founder of the Indonesian preprint archive. And his comment to the session, he couldn't attend, so he sent his comment beforehand, was, "In the digital connected era, the meaning of internationalization in general has shifted from English-only conversation to digital discoverability." And he says, "The context of the above sentence relates to the mindset of people from Global South, including Indonesia, that internationalization means publishing in international language, jumping into the metric or ranks that have not been built upon the nation's need and original purposes." So I was wondering if you share this sentiment and if you had any comment on it. Umar, can you hear me? This was actually a question for you. If you had any comment on that.
Okay, which questions is it?
So the statement that I just read out. Do you have any comments or do you have the same feeling about that? I'm also going to post it to the chat right now. Okay. But if there are no immediate reactions, you can think about it for a bit. We can also invite others if they have comments or questions at this point.
Mm-hmm.
So I can see several people typing. Is there also a question with a microphone, maybe?
Okay.
Well, I will ask a question. So first of all, congratulations. This is Peter Murray Rust. To what extent can you get government support from this, either from single countries or a confederation of countries?
Umar, do you have any response to this question?
Currently, at the moment, we currently don't have any government or institutional support from the continent so far, but we are still advocating and creating more awareness, because there are areas scientists are still lacking knowledge about what a preprint is all about. And some of them, they don't even believe it existence, and some they believe it existence, but they don't go in depositing their papers to preprint, because mostly some of the researchers they publish papers only when there is promotions or something like that. So there is time actually to look around and find out how we can approach the governments and institutions in particular to support the progress of this AfricArxiv.
Thank you very much. Yeah, another member of the AfricArxiv team has just written in the chat that the African Union is lobbying for open access, and that generally AfricArxiv agrees with the subta sentiment. There is a need to proactively invite researchers from Africa, Latin America, and Asia to build a functional infrastructure. And also we stress the importance of local and regional languages. And there was another question in the chat. Any ideas how to improve collaboration between English-speaking and non-English speaking scientists? I look forward to the improvements in AI machine learning networks in translation. So do you think that's also a way to go, Umar, in terms of connecting English-speaking and non-English-speaking researchers?
Yeah, there may be a way. Maybe we can look at it on this angle. I don't know. Maybe looking at some scientific papers that will be deposited should be, if you are coming from this language, maybe we can say, okay, let the abstracts be in English formats while the rest of the documents be in the local format, so that the English community will be able to grasp the idea about the scientific contents of the work.
Interesting. Thank you very much. Yeah, I think at this point we can move on, because I can also see that in the chat the discussion is now also moving heavily to infrastructure and tools already. So thanks, Umar, for your presentation. And I'm going to take the presenter again and give you a quick introduction to our second part, our second block, which is essentially about tours. And I think in the past few years, we have seen innovation in discovery tours, but for a long time, there were only a few players, and maybe the most prominent among them is Google Scholar. Many researchers use it to this day. But prior to the session, I gave myself a bit of a challenge, and I thought maybe I can also get an overview just using Google Scholar, right? And so I took to the interface, and sorry about that, and I typed in COVID-19, and then I got the message that I have 210,000 results. Now, I don't know how Google comes up with this number. I went to the 10th page, and then it goes down to 150,000 papers, but it's still way too much. Not that much literature has published on the topic so far. If you put it in quotes, then it goes down as well, but it's still way above other estimates. So yeah, I was struggling with this number a bit. It doesn't seem to be very reliable. But then I looked at the actual results, and I realized that they are very unsorted, and there's very little context to them. We can see, okay, maybe the number of citations, but if you look at the different papers, so I don't know if this is really the most relevant paper for my own interest. We have down here a paper, COVID-19 in Italy, so maybe this is an epidemiological paper, but there is no indication that would tell me otherwise. We have an interactive web-based dashboard to track COVID-19, but I don't know, is that to track the cases? Is it to track the literature, other papers? What does it do? And so I think what we see here is that Google hasn't invested in this interface at all. It basically looks the same as it was 10 years ago. If you look at screenshots, some of these things they have moved, but essentially you have the same filters and the same functionality as 10 years ago. And your only chance to really get an overview of the topic is to go through the different hits one by one by hand and just examine them whether they make sure in your particular case. Of this is, of course, that it takes a long time before you then can get an overview, a mental model of the field, before you know the most important publications, the most important topics, and the most important authors. And this is time that we don't have in an epidemic, but this is time that we actually never have. If we are completely honest with ourselves, unless it's maybe the first year of a PhD, discovery is always a process that falls short and it ends before it should. And this is a big problem. It wouldn't be as big of a problem if we could reuse the data from Google Scholar, right? If we could then say, okay, maybe this interface is outdated, let's just build a new one. But unfortunately, this is not possible because essentially it looks like this. We have institutions, researchers, and publishers, and they produce the research and they put it out. Google then takes their data and creates the search engine. But the problem is that on the other end of this equation, there is just the wall. So you can see here, there's no way to reuse or republish this data. So something that you would need to be able to do if you want to build your own tool on top of this. And so everything that Google Scholar indexes is only discoverable within the system. And if the piece of research that you're looking for is always on the 10th page of the search results, well, then it's invisible to you and it has essentially become dark knowledge. And that's why I call this war the war of dark knowledge. And it's even worse than a pay war. You cannot even pay to get around it because it's essentially the business model of Google that it doesn't allow you to republish and reuse their information in any other form than you looking at it. And unfortunately, that's the business model of almost all proprietary vendors of discovery software, including Web of Science, Scopus, and ResearchGate. Some of them have APIs, but essentially it's not possible to republish the research, so you cannot build tools on top of them. Thankfully, there is another model that emerges, the open discovery infrastructure. And in this infrastructure, reuse is actually a very important property. We again have institutions, researchers, and publishers, and they also contribute to libraries, archives, repositories, and aggregators. And you can see on the right-hand side some of the institutions and organizations and repositories that are out there. But of course, there are maybe at this point hundreds of thousands of these repositories, of these organizations. And they are already part of the open discovery infrastructure because what you need is an open data interface. An open data interface to your database. And this can then be used by, for example, by meta aggregators such as OpenAIRE, Corebase, or Wikidata. And they create massive indices of scholarly knowledge. And then we have the value-added services, and they now reuse the meta aggregators because the meta aggregators, again, they have an open data interface. And so we have visual discovery services such as Open Knowledge Maps, ReFigure, or Scoria, but also ORCID and Paywall and Content Mine. They reuse data from the open discovery infrastructure. And with that, we get a cycle of continuous innovation. Because suddenly we can build on top of each other. We can use all the technologies that have been absent, like semantics, visualization, recommendation, all these things that we need to build better tools. And there are many cross-links between the actors in this system, because sometimes a value-added service might directly build on top of a library. Of course, the value-added services also, they give back and try to enhance then the data also that's already in the system. Sometimes researchers might directly go to a meta aggregator to get their information there. So as you can see, this is a very, very dynamic ecosystem. It's the biggest driver of innovation in early communication. And now I'm happy to introduce you to 5 different infrastructures and tools that come out of this open infrastructure and that help us to combat the discoverability crisis. And first up is Alessia Bardi. She is part of the Italian National Research Council, CNR, and she's also a member of OpenAIRE. And she will now present the OpenAIRE gateway for COVID-19. So I'm going to make Alessia a presenter right now, and then now I will ask her to take it away.
Thank you very much, Peter. Okay. So my name is Alessia Bardi and I work for OpenAIRE. So before I go through our activities for helping the fight against COVID-19, I would like to introduce a little bit OpenAIRE and what it is. So OpenAIRE is an infrastructure that is a pillar of the European Open Science Cloud. We are one of the implementing projects of the European Open Science Cloud. And we are trying to promote, to foster, to support the implementation of open access and open science in Europe and beyond. In fact, we have collaborations with institutions, organizations from all over the world, including Japan and South America. So how do we foster the adoption of open science principles among researchers and research managers and national policymakers? We have 3 pillars of action that you can see here. So policies, training, and services. So we support the alignment of policies, national and international policies on open access and open science. We have training sessions that can be done face-to-face or virtual, like we are used to do it in these days. And these trainings are for teaching how open access can be done, how open science can be done in a sustainable way. And finally, we have the services. So the technical services that support the implementation of open science principles. So we're trying to overcome some of the barriers that researchers and research managers face when trying to do science in a fully open way. One of the main output of this initiative is the OpenAIRE research graph. So what we do is exactly what Peter was saying before. So we are these meta aggregators. So we collect metadata information from a lot of scholarly communication sources from all around the world. And we are collecting from more than 10,000 institutional repositories, for example. We collect information from Crossref, from Microsoft Academic Graph, from open access and open access journals, and also some non-fully open access journals. And when we collect the metadata from the sources, we are trying to extract the information therein in order to build this graph where all the entities of the research life cycle are linked together. So you have, for example, the publication, which is linked to the funding projects, that is linked to the organizations that are of its authors, to research communities. And and also to the supporting datasets and software, because we don't have to forget that a research that is described in a publication is often backed up with the underlying data and software that has been used. So what we end up is with a research graph with more than 100,000 research outcomes. So publications, research data, software, and other types of research products. And then the COVID-19 exploded, and we said, okay, we have to do something. We have to help researchers at finding COVID-19 related research. So how can we do it? Is it possible to do it with a simple search, an advanced search on our Explore portal? And we say, it's going to be hard. So we decided to set up a dedicated portal, a dedicated gateway for this. And so our question became, okay, how can we identify coronavirus related research in the data so that we can build this specific portal on top of it? Which are the fields that we should use in a search? Which are the search terms that needs to be used? Are there any specific vocabularies to be used? Another important question was about the criteria. So if I use a predefined query, is that enough? Will I get everything? And in addition, as OpenAIRE, are we really including the thematic sources that are relevant for COVID-19 and coronavirus? So based on the answers that we gave to ourselves, we came up with an approach. And the first thing is that we were not able to take some decisions, for example, on the subjects or on the subject classification schemes, because we needed domain experts. So we decided to involve experts, and we had a call for experts among researchers, librarians, and research managers. And they helped us in shaping the COVID-19 gateway. And thanks to these experts, and also thanks to the community at large, we created a public list of data sources, so thematic data sources about COVID-19 and coronavirus. And if you're, I will share the slide later, so that you will find the links to see the list. And if you want to provide some additional sources to be added. So once we involved the expert, we got the knowledge base from which to start from. So an extensive list of keywords to be used, and classification schemes, vocabularies that we can use. And we use that for mining metadata and the full text of open access publications. And whenever we found the proper keywords in the text or in the metadata, we are able to tag these publications and datasets as relevant for COVID-19 research. And then we discovered that there are also projects that are working on this. And we said, okay, so if there are datasets and publications which are funded by these projects, then they are relevant, and we added them into our gateway. But still, something wasn't included. So we also added the possibility to manually add the metadata about research outcomes that are related to COVID-19, as long as they have a DOI. So when we put everything into place, we released the beta COVID-19.openaire.eu, which is the single entry point where you can find everything related to coronavirus that we could find in the OpenAIRE research graph. So this is the homepage of our gateway, and you can find the link on the chat if you want to browse it and look for it yourself. And to ease the discovery, of course, you can perform search by titles, authors, abstract, DOI, or even ORCID IDs of researchers. But we also offer other ways through a faceted search that allows you to select research outcomes that are funded by a specific funder, or a specific project, those that are open or not. You can browse by type so that you can decide to exclude, for example, the preprint and only look for articles that have been published in journals. And also finding those that have been published in a specific journal. So, for example, you can see there are 105,000 articles in PLOS ONE, for example. And something that I really find interesting is that we are able to find connections between research on COVID-19 and different disciplines, like science and innovation policies, or digital humanities and cultural heritage, and agricultural and food science. So how all these different disciplines are affected and work on the same high-level topic of coronavirus. So all fields of research are affected and are interested in these epidemics. And the same applies also to research data. So you can find here a couple of data sets from Mendeley, and you still have the same possibilities for finding the data sets via faceted search. So to sum up, because I think I'm already late, so we collect metadata information from more than 10,000 institutional repositories and journals. We get metadata from Crossref, from DataCite, from EBI, from other sources, and we apply mining on the full text and on the metadata. And we feed the OpenAIRE research graph. We include also other sources which are specific to COVID-19. For example, the World Health Organization is keeping an up-to-date data set of all the publications, which is updated every day. So this is also inside the COVID-19 gateway and the OpenAIRE research graph. We set up as another community where it is possible to deposit data sets, publications, presentations, every kind of research outputs. And we decided to have this community which acts as a container of research about one specific topic, in this case, the COVID-19. So via the dashboard, you can, of course, discover, navigate, and link. And you can also find the links between the publications and the datasets. And final, open APIs. So do you have any questions?
Thank you, Alessia, for this very interesting overview of the OpenAIRE services. Yeah, are there any questions or comments to this presentation? So I myself have a question for you. So how was the reception of the services that you put out? Did you have any feedback from COVID-19 researchers?
Not Not yet. I mean, we had some feedback more on the user interface side. So we had suggestion on how to improve the discoverability of the research outcomes in the portal. But in a way, who's using the portal is aware that we are not a domain-specific portal. We are collecting information from different domains, so we cannot really have a specific search that goes, for example, into the data. But still, we know that we have a lot of ideas for improving.
Yeah, absolutely. I can imagine that. Thank you very much. There's also a question from the chat. So how does OpenAIRE discover book literature?
Okay, so as I said, we collect the metadata from institutional repositories. And so we are able to collect the metadata records about books of where researchers, books that researchers write, because they want to, add this information in their institutional repository for many monitoring reasons. So probably we don't have the full text of the books, because open access books are still few with respect to journal articles. Although I know that there are several content providers, data sources that give open access books, and I don't know actually if we are already collecting all of them, but for sure this is something that we should work on.
Excellent. Thank you very much. Yeah, at this point, I would suggest we move on. Alessia, thank you very much for your presentation. And now it's a pleasure to introduce you to Peter Murray Rust, who is the founder of ContentMine. And PMR will talk about the openVirus initiative. So I'm going to make Peter a presenter and we'll ask him to take it away. PMR, are you there? Ah, yes, now I can see it. You're still muted, I think.
Okay. Can you see my screen?
Yes.
Okay. So thank you very much, Peter. We've worked together in the past, and I congratulate you on Open Knowledge Maps, which I think is a tremendous part of the infrastructure. ContentMine has a political agenda and a technical agenda, and the idea is to make citizens, not just academics, empowered with scientific knowledge. So this is all about trying to get something out to citizens. So we have to argue the political thing. Much of the problem is that publishers stop us using machines to read the literature. We've heard why we need it. So we develop tools to do this, and we fight for the right to use them. And these are some of the wonderful people who over the last 3 or 4 weeks, perhaps 2 months, have volunteered completely free to help with this. We've been running meetings, collaborations for over 6 years, and here you can see 2 of Peter's colleagues in Austria, Stefan and Chris here. So 6 months ago, we were doing this for climate change, because that's going to destroy the world as well, and even more surely. So we were doing that until February, when suddenly COVID hit, and we thought we would turn our technology over to COVID. So we know that knowledge can prevent viral epidemics. The Ebola outbreak was predicted in 1984, but it was forgotten. The paper, which you'll see in the next slide, is still paywalled. Nearly 40 years after, that paper predicted the epidemic, and it's behind a paywall. And so we believe that with our tools, which anybody have, they're completely free and open, all you've got to do is to discover this single paragraph. And that paragraph, if you index on country and disease, it would immediately tell you that there was going to be an epidemic in Liberia of Ebola or Marburg. And in my view, it's shocking that this sort of technology is not available to people. So how much is open? We hear that open is winning. Well, it isn't. Here's a major publisher. And if you step away from COVID and ask about things like face masks or social distancing, things like that, you will find everything is closed. So we look for social distancing, and here we get nearly 500,000 results, and only 5% can be read by people who aren't in universities. So we are complacent about the fact that actually most knowledge is not available. And this is the sort of thing which a policymaker might want to read. It's about predicting social distancing in an infectious disease epidemic. And we hear about this on the radio every day. So we're going to change that. And these are some of the things that we want to do. We're using Europe PubMed Central. We've deployed tools called Get Papers and AMI for several years. Over the last 2 years, we've worked with Wikimedia Foundation on Wikidata, and we've also talked to Crossref and the preprint servers. And doing that opens up a whole new set of knowledge. We're working with my colleague Geeta Yadav in Delhi, and these are two wonderful new interns who just started, and they're working to use these tools for scraping the literature for COVID. So what do we do? Well, the simple statement, it's technically complex, but the simple statement is you scrape the literature, you have to clean it because it's in a terrible state, it's PDFs and all sorts of garbage. We then annotate it using dictionaries, WikiFactMine, and then we display and publish it. We can use any source so long as we build an adapter for it. So at the moment, we're using Directory of Open Access Journals, which have got nearly 5 million items, Bio and Med Archive with 50,000 preprints, Ethos, the British Library theses, and we've been talking to Ariana Becerril Garcia in Mexico, who runs Redalic and America. And I think it's very important to reach beyond the European, North American bubble. So Clyde Davis, my collaborator, did the following query. He took DOOJ, he asked this question, and he found in 100,000 abstracts, 45 hits. That means that in 2,000 articles, you would find that. That's the sort of ratio you're looking at in the whole literature. And remember, these are not just bioscience, they're all sorts of science. Andy Jackson did the same on the British Library. He's written some nice blogs, which you can find there, where he's downloaded them and indexed them. So this is summarizing our tools. I'm not going to go through them, but again, it's scrape, clean, annotate, and display. We create dictionaries, and the point here is you can create your own dictionary in 10 minutes using Wikimedia. Or you can create your own dictionary, which takes a little bit longer. And you can see here a whole range of things: insecticide, funders, countries, all sorts of things. You then annotate the paper, and here you can see the frequency of things. So in this particular paper, this is one paper, we've got countries and diseases. This is a full paper here, and we can then do a co-occurrence matrix here, where you can see, for example, that there are highlights in China, pneumonia, SARS, and so on. And all of that, it probably takes 5 to 10 minutes. So this is a very rapid thing. And the point is that it's done completely on the reader's desk. It doesn't need any servers to help it. Sorry, I've gone backwards. That's the architecture. I'm not going to take you through it, but the details are there. This is something we proposed to welcome. We didn't get funded, but the architecture works. You can actually put the whole thing in a box. So this is a Raspberry Pi. You can buy a disk at the local hardware store. You can put all of those for less than 100 quid into a box, and then you've got the whole scientific literature in a box that you can take anywhere and use wherever you've got a screen and keyboard. So that's the model. We'd like people to help us. These are some of the things that we want, and thank you very much for giving me the chance.
Yes, thank you very much, Peter. I'm now very inclined to get a box that you just described. That would be really cool.
Yeah.
Yeah, absolutely. Yeah, thanks for the presentation. So, are there any questions or comments to PMR's talk?
Hi, this is Girija from ReFigure. A great talk, looks so exciting. So as a researcher, when can I engage with this to look at this sort of to look at the display of the data?
Well, you can do it today. It ranges between pre-alpha and good beta, right? Okay. It depends what you want. So it's a toolkit. It's like, you know, in the same vein as R or the Unix toolkit or whatever. You put it together to do what you want. So I'll actually go back to a valuable slide here from Clyde, not that one. This one. So here, Clyde has got a workflow tool called KNIME, and you can put the modules together to do whatever you want. At the moment,
the input.
Sorry?
I can choose the input sources and all of that.
Absolutely. Now, we've got 5 input sources at the moment, but it really depends on the scrapers. The publishers make it incredibly difficult to scrape. Europe PubMed Central has a wonderful API. I would say the preprint servers, they're very collaborative, but they probably need to have more RESTful APIs.
Thank you so much. I also have a follow-up question. So what would the display look like? And you had mentioned in your last slide that you need queries. You need people to submit queries, or you need beta queries?
We want to do the queries coming back here. We want people asking meaningful questions. We're building the tools, but we want to know whether people want to ask about face masks or aerosols or social distancing or whatever. We'd really like 1 or 2 mainstream COVID users to stress the system.
Cool.
But you can ask any question you like of the scientific literature.
Okay. And if we have a query, should we send it to you, submit it on the web or on GitHub?
No, the whole point is that you download the toolkit. And then you run it, you learn how to use it. We did this in India last year. So let me go back to my Indian colleagues here. Where are they? They're wonderful. Okay, so Geeta had 3 other interns last year, and we built a toolkit for doing crop research. And there's a whole tutorial there, which we're now adapting to openVirus. So you can use it as from today. But, you know, it helps if you're forgiving and patient, if you know what I mean.
Yeah, thank you.
You can see they're writing a tutorial there. That's Priya and Karina are writing it.
Thank you very much. We have great talks. Also a comment from the chat that I'm definitely echoing. One more question. Let's see, is there anyone who would like to make a question or a comment at this point? Doesn't
If
seem
any
to
of you've
be.
got repositories, I'd love to work with you. We're talking to the Indonesia archive about this, and we'd love to ship them our software, and the same would be true of any archive.
Awesome. Yeah, very much for taking us through Content Mine and openVirus, and we will hear a lot from that, I'm pretty sure. So in the interest of time, I think we should move on now. And the next presentation actually one that is Joe. So I'm going to take me to launching. What we're talking about is COVID. Oh, I just got the message that I dropped out. Can you hear me? Okay. Now it seems that people can hear me again. That's good.
Yep.
You didn't miss much, but a few introductory words while I was starting my screen share. What Joe, Akin, and myself will be presenting now is COVIS, which is a curated visual knowledge base for COVID-19 research. And the jumping off point for us was that many labs and researchers have turned to COVID-19 research, but they do not have prior knowledge or adequate preparation at this point to do it. And for them, it's really hard to get an overview of the literature that is out there right now, and then also to keep up with it. And in this spirit, ReFigure and Open Knowledge Maps started this collaboration. And the main interface is to this tool is a knowledge map that you will be able to see in a second. And as in any other knowledge map, for example, on openknowledgemaps.org, you can see that the main areas are here visible at a glance. So we have immunity, host biology and clinical findings, epidemiology, diagnostics, therapeutics, viral biology, vaccines, and by popular demand, also introduction to coronavirus research. And these are 8 relevant research areas within biomedical research when we're talking about coronavirus. And to each of these bubbles, you have now papers and other resources related to it that all represent seminal works within the field. So that are really interesting for people who are coming to the field and who want to get this first overview, these first papers that get them started and set them on the right track. And as you can see, we don't only have papers, we also have data sets, preprints. There are also reviews in here, refigures, and Joe is going to say in a little while what refigures are. And you will then can also filter it down. For example, if you only want to see the journal articles, then you're presented only with these 2 results. Then we also have tagged them with free access or open access, also whether they are peer reviewed, for example. And there are also comments here that give additional context to the study or the paper and probably help you a lot to contextualize it also within your own research. And once you found a paper that you're really interested in and it is truly open access, then you can view it within the same interface. So all of this is meant as a jumping off point, and it's powered by a data source that is a collaborative spreadsheet. And of course, we're aware that this is not an open infrastructure. But for us, it was a possibility to get started with a collaborative interface before we have to create our own. And it's also an interface that is already familiar to other people around the world. And all of this content is managed by ReFigure. And so I'm going to hand over to Joe, who is now going to tell us more about the content and the community management.
All right, thank you, Peter. This is Joe. Can you hear me?
Yes.
All right, great. Thanks, Peter, for the pardon me, invitation today. I think this is a very exciting session. My name is Joe Akin, and as Peter mentioned, along with Girija, we have created ReFigure, and we have curated the data sources behind the COVIS. So our team represents a deep experimental experience at the bench, as well as a deep knowledge in immunology. And we've complemented that with advisors in medical doctors and pulmonologists and virologists to create this set today. And as Peter mentioned, it's meant to be a jumping off point for researchers that are new to the field of coronavirus and COVID-19. And we do hope this is a jumping off point, and as Peter alluded to, will be a seed that can lead to community feedback and collaborative curation. So as Peter mentioned, if you can immediately see how many documents are available in the knowledge map right now, which is 48 documents, and you can go to the data source tab. But to give you a little bit more detail on what the repository looks like right now, this is the annotated spreadsheet with all of our curated documents. And as Peter mentioned, they include seminal findings like this paper highlighted here, which would be the New England Journal article that first described patients with respiratory distress in Wuhan, where they saw the ground glass opacities and rapid lung degradation. Along with those seminal papers, we've also included preprints. So we could see an example of that in this representative article up here. So this is a bioarchive showing that reinfection was not occurring in macaques. Another very important topic in the pandemic. Can people become reinfected? And so we've included data of a more recent nature and that is not peer-reviewed. And finally, as Peter mentioned, we've also included ReFigures. And so why ReFigures? And so what we found was for particular research questions, data was evolving so rapidly, and these publications and data drops were of a very quick nature, maybe not representing, a 6-figure long form article. And what was most convenient was to use ReFigure as a tool to put all those findings side by side and linking the underlying publication. So what is a ReFigure? I wanted to quickly show you an example of one. So we'll look at this ReFigure that is evaluating hydroxychloroquine as a therapy in COVID disease, and that is represented in COVIS. So this is that ReFigure that's linked in the COVIS portal. And you can see that we've been able to collect 3 recent studies that were done looking at hydroxychloroquine in COVID patients. We have the first study in France. We have a larger study that was done in China, and then an even larger study, which is represented by a preprint here on ReFigure, that was also done in China. And along with the actual data, either textual or figure-based data, you can, I've annotated this with some important information about those studies. So we can see that that this study here, which is part of the controversy surrounding HCQ use, was not a randomized control study looking at viral load, whereas the two following studies were randomized control studies with different outcomes. And so very quickly you can see a snapshot of how that data is evolving without having to navigate to the 3 separate articles. Of course, you can navigate to them and bookmark them here in ReFigure if you would like. So I wanted to just give you a highlight quickly of the content that we have curated in COVIS. And we really hope, as I mentioned, that this is a jumping off point, that researchers would like to contribute and start a more broad-based collaborative model so that this can become an impactful site for coronavirus research and forwarding the field during this very critical pandemic. So thank you again very much to Peter and his team. It was great building this. I'm amazed at how far we've come during this time. If there are people out there that are interested in contributing, you can email us at refigure.org, or you can email Peter, and we'll start working on that collaborative curation model. And thank you very much for your time. I'll take any questions.
Yeah, thanks, Joe. Are there any questions or comments at this point? So unfortunately, we were not able to share a link with you today because we're still in sort of a pre-alpha state, and we don't feel comfortable to share it right now, but we will do that in the coming weeks. We started this as a pure volunteer effort, and now we also got a small co-creation funding from EOSC Secretariat, so this also was a good boost for our efforts. Hopefully in the coming weeks you will then be able to also use it and interact with us also from the website. So we have a question from the chat for Joe. In terms of the annotations on the ReFigures, who adds those? And is there a potential for subjective comments, opinions to be introduced that might wrongly discount certain studies?
Thanks for that important question. Right now, we are limiting participation on the COVIS curation. We're very interested in people that are interested in contributing, having ideas they want articles included. But right now, it's restricted right now to the ReFigure team. Anyone for the ReFigure platform can go out and create a ReFigure and comment on the science and bring their opinion to light. We have not developed the commenting platform yet, but so in short answer, there's an editorial process for this COVIS effort with open knowledge maps, but there's not a curation piece to the larger ReFigure platform. I hope that answers the question.
So following up on that question from Ellie Masterman, I wanted to ask Peter and Joe to perhaps comment on the need for human curation given the computational approaches we have seen.
Yeah, sure. So from mine and Open Knowledge Maps point of view, an algorithm can only always make a suggestion, but it cannot produce an accurate overview of a field in a sense that we all look at science and research from our very own subjective perspective, right? And chemical physics will have a different view than physical chemistry on the very same subject. And this is exactly where I think the human curation is so important, because we can then have two maps of the same thing, right? And they may be curated by different researchers, and then we can put them next to each other and say, okay, where are the differences and what things may the one subdiscipline have missed that the other doesn't have, right? And so especially within the torrent of the current research that is out there, I think it's important to have these pieces that everyone agrees on and says, okay, this is where you actually should get started. And I think this can be very valuable to the community, and with the comments and other functionality and annotations, I think this is something that the pure computational approaches are missing at the moment. Did you want to add anything to this, Joe?
Yes, Peter. I think that I mean I don't think that that we're solely AI based approaches or human curation. I think that a mix of the two will ultimately be what will work the best. I think there's some precedence for that sort of hybrid approach. And with respect to scientific literature specifically, I think we have examples where crowdsourcing has been very useful and can work very well. And that hasn't extended, as far as I know, into scientific literature and review, just for some of reasons that are just from conventional practice. And I think it's great to have people with like minds and very diverse ideas to come to forums like this and talk about possibilities. What I think you see with this, what we're hoping to achieve with the collaborative curation model, is to test the feasibility of some of these approaches. There is subjective things integrated, even peer review publications. And in fact, Girija and I were just talking about, as that conventional practice and the system of peer review gets stressed, especially with the demands of the current pandemic, it's possible that we see not properly validated results now. In addition to the dark data that Peter mentioned, we might actually have some unvalidated data out there in peer-reviewed sources.
So since we're already at this discussion, I would like to quickly pick up on a point that was earlier, and I just don't want to go it unanswered. So this goes out to Joe and Girija. Do you think that personalized streams of knowledge would also be relevant, or of scientific knowledge? For example, the ones that Meta provides, where you can sort of add your own research interests, and then it will curate a stream for you. Do you think that this is interesting or relevant for your work?
I find those very interesting. I think over the years I'm suffering from fatigue of trying a few of those, because at least I tried it recently, so I'm sure they have improved, but very often I was missing some things. The stream was getting too narrow was my only problem. Again, as you defined, it was hard to fine-tune the stream to my interest, because the stream was probably being driven by text-based text mining and things like that, which didn't often capture the scientific finding behind it. But yeah, those are useful, and again, like they will probably feed into the human curation and the scientist's thinking process.
Awesome. Thank you very much. Okay, then I think in the interest of time, we will now move on. And next up, we have Konrad Lang from Graz University of Technology and CyVerse Austria. And he will be talking about CyVerse as a computational infrastructure and data management services. So Konrad, please take it away. I just have to make you a presenter again.
Okay.
All right. it. So now you should be able to do it.
Okay, so Peter, thanks for the invitation, and I'll keep it short as we are a little bit late behind time. So I'm from the Graz University of Technology, Konrad Lang, and I'm also building up CyVerse Austria as an infrastructure for the University of Graz, Medical University, and Graz University of Technology. 1 second. Okay. So CyVerse itself is an infrastructure that provides you with means to do your data management, add metadata to your data, share data across storage devices, institutions, universities, but also adds another layer that you can use to analyze your data in a way that you containerize your application. Whenever you have some analytics going on, you can put them into Docker or into Singularity and run this on data that is also available in the system or from other sources, and share this analysis in combination with your data. One other point we come to is you can issue DOIs and also upload data to different archives out of CyVerse. Sorry, CyVerse itself is based in the US, part of the University of Arizona and other partner universities as an NSF-funded project. We in Austria, and particularly, as I said, University of Graz, the Medical University, and the Graz University of Technology, decided to deploy this as CyVerse Austria. There were many different aspects why we didn't just use the US system. One of them is the GDPR, because data would then also be uploaded to the US, and a lot of research projects might not allow that. So Biotech MedGraz, that was our funding organization, provides this to the researchers of all 3 universities at the moment, but there are now plans and then the starting project in July to attach or add a lot of other universities, at least from Austria, to this platform and to provide data sharing and resource sharing for computational resources, at least for Austrian researchers. So coming back to CyVerse, as I said, founded in 2008 by the University of Arizona, and it is mainly funded by the NSF in the US. One good thing about CyVerse US is it is freely available to anybody in the world. So whoever wants to use resources can sign up at cyverse.org. You get at least 10 gigabytes of storage space and access to their HPC resources, as long as you do not run any hostile operations there. You are free to use this. There's a whole range of different products available, from DNA analysis, image analysis, and so on, down to different HPC systems that are available on the US side. One part of CyVerse is also called Data Commons. This provides a pipeline where you can take your data and publish it to NCBI, either the sequence read archive or a whole genome sequence archive, I think is the second one, and also the Data Commons portal, where CyVerse is hosting the data and issuing a DOI for you. Secondly, it provides you the way to anonymously search data, where we make a distinction between curated data, where we ensure that metadata is available and everything is labeled in the right way, or also in community release data, where everybody can share his uploaded data together with analytics that have been containerized for everybody else. Everything else can also be used in this discovery environment where you can run your analytics and search for data. So one example use case that we have implemented here at the umbrella of BiotechMed is some metagenomics analysis, where there is data from the Medical University of Graz and data from the Graz University of Technology. Both teams did work in the same environment. One is from biotic surfaces, the other from abiotic surfaces. The interesting thing here is data from the Medical University was not allowed to leave the Medical University, so we were using CyVerse to bring in TU Graz data, automate it, and run analytics on the system using Jupyter notebooks. And now analytics is going on to find similar gene sequences for this. And another big project we are involved is FastCure, where CyVerse is used also to ensure the data management between all the project partners and also the encapsulation of the analytics. So FastCure aims to build up a cloud-based system now triggered by COVID-19, but this should also be something for the future where very easily new institutions, new laboratories can drop their data or can access a whole range of HPC resources to do calculations with their data. And as promised, I said I keep it short, so thanks for your attention, and if there are any questions, please either in the chat or yeah.
Thank you very much, Konrad. This was a very interesting presentation, and so I'm wondering who has questions, who has comments? I can see Charles coming on. Charles, did you have a question for Konrad?
No, not at the moment.
Right. So
Okay.
actually, I have a question for you, Konrad. So how was your experience in setting up CyVerse? Would you do it again? Would you choose it again? And what was the user feedback, or what is the user feedback so far?
Experience was setup is more like a lot of things to be done on the infrastructure side, and a lot of the things to be done to get contracts and GDPR related things in place between universities. Yes, we would do it again because it's all open source, it's freely available, and it gives a lot of power to our researchers. So they can upload all the data, they can share the data, and they also are now starting to containerize their analytics, so this can be reused together with the data. So you not only get a publication with a DOI to the data or a DOI to the container, you can get a link from your publication to the whole data set and to the whole analysis to be run or to be reused afterwards. So this looks very promising for us.
Yeah, thank you very much. So there was a request for you to post the links to what you just presented to the different systems in the chat or in the notes. So I would ask you to do that. Any other questions or comments at this point? Do you already see increased reuse of data within the institutions?
It's starting. So we have between the Technical University and the Medical University a bit more reuse, and there were some new collaborations between Institute of Psychology and some others that are now in the works of getting this set up. So to add, this has gone fully operational in January, February this year. So we are really now starting training our users and getting this rolled out to the all of the universities. Yeah.
Thank you very much. All right, then I would say again, thank you for the presentation, and let's move on. And now I'm happy to introduce you to Charles Watkinson of University of Michigan and Michigan Publishing, and Mike Roy of Middlesbury College and Lever Press, and they are going to take you through a backend discovery workflow that they have implemented for their presses.
Okay, Peter, thank you very much. And thank you for a very stimulating display of a lot of different interesting tools. What we're here to do really is to talk about a type of content that hasn't been discussed a lot, and that is books, and to make a plea for including books in these open source discovery infrastructures. So my colleague Mike Roy and I are ready to talk a little bit about books. First of all, I just wanted to say that books really do matter for understanding COVID-19 and will continue to matter and matter even more in the future. There are a lot of books published every year, not as many as journal articles, but around 86,000 monographs are published a year, according to Digital Sciences analysis. And they are a lot in humanities and social sciences, but also in science, technology, and medical fields. And what books offer is a space for synthesis and reflection. So we'll see a little bit of a lag before books start to come out around COVID-19, but they will be starting to stream out next spring. And they will provide an excellent sort of framework for understanding the cultural bases, the social bases for our experiences, and the long-term future for our society as the COVID-19 pandemic continues and dies down. They're also very interdisciplinary in nature. But the environment for discovery of books is very different. There are lots more smaller book publishers than there are journal publishers. Journal publishing is a bit more monopolistic. There's also been a much slower progression from print to digital for books, and so there's a lack of digital identifiers and metadata possible to scrape, especially metadata that indicates whether a book is open access or not is much harder to come by. And there's a reliance on intermediaries and aggregators that Mike will talk about a little bit more. Open access does bring these extra issues into really sharp focus. And one of the things I think we've seen today is there is a bit of a disconnect between open science and humanities cultures. Books do tend to get forgotten a bit in some of these discovery projects. Book intermediaries tend to depend on revenue for services. So many of the biggest intermediaries rely on a business model where they take a percentage of the retail price of the book for the value-added services they provide. And Mike will talk more about that. There is book infrastructure for open books developing. Many of you will know the Directory of Open Access Books and OARPN, and there's a very important project run out of the UK, the COPIM project, and these are all links here as well. Who are we? So general context is I'm the Associate University Librarian for Publishing at University of Michigan, and I'm in charge of a division of the library called Michigan Publishing, which is a supportive infrastructure for OA books as well as data and other kinds of publications. And one of the projects that we support is Lever Press, which is, on the one hand, a publisher committed to a form of open access publishing which doesn't rely on author fees. And that's made possible through financial support from around 50, mainly liberal arts college libraries. And those libraries are participating in LevelPress really to advance the open access book and to help push books into the conversation more. And then Fulcrum is the publishing platform that was developed at University of Michigan, and that is one of the building blocks here. It's an open source book platform committed to rich data and interoperability. So what I'm going to do now is I'm going to pass over to Mike, and he's going to lead you through some of the elements of the book infrastructure, discovery infrastructure for books. So Mike, over to you.
Okay. I'm working on it, starting to make this happen. That's not what I want.
Okay, so
can you hear me?
Yes, we can.
Okay, you don't want to see my hair anyway, so let's just skip the video. So as Charles pointed out, I'm Mike, where I work at Middlebury College, and I've been involved in this open access press. And when I saw the call for this panel, I thought it would be a place to kind of share what we've learned, share with you some of the things that we bump up against, and try to learn from you about how we move forward in this space. And so what I'm going to do is walk you through a fairly complicated diagram that you can see here, which sort of shows how information flows from the point of publication out to what we hope will be the laptops and tablets of our readers, and all the different steps that it takes along the way. So Charles, can you go to the next slide? So it's also, as I said, it all starts with this publication that we create, which is takes the form of either a PDF or an EPUB 3. And from there we take create metadata, which we store in this system called the Firebrand Title Management System, which creates this ONIX file, which is an XML file that contains metadata about the books. And then the EPUBs and PDFs themselves go into both a system called the BiblioVault based in Chicago, and then into this platform that Charles mentioned that they're doing at the University of Michigan called Fulcrum. And Fulcrum is, as he mentioned, open source software that you can run yourself, or that I believe Lyricist will actually run it for you if you're interested. And kind of along the way also, which another topic that hasn't come up today, is we also drop copies into clocks and AP Trust for preservation. So if we go to the next leg of this journey, is really about aggregation and discovery. And so from these two systems, BiblioVault and the Firebrand Title Management System, we regularly send information to 3 aggregators and 3 discovery services. So the aggregators that we send them to are JSTOR, Project Muse, and Open. And then Open, in turn, links up to the Directory of Open Access. And the discovery lists are the EBSCO discovery layer, ProQuest, Summon, Primo, and OCLC WorldCat. We put MARC records into those. The next leg of the journey is really flipping into thinking about where we actually enter into actual people discovering things. If you could hit the next slide. Is thinking about libraries who are interested in making sure that their researchers have access. And so they can download records from Fulcrum. They can download MARC records and add to their local catalog. And then they also can connect, make sure that their local discovery services are in fact indexing JSTOR, Project Muse, and Open, which is where they can make sure that they find access to this. And one of the things that we've been thinking about is thinking about where researchers are apt to go, and have tended to not think about kind of siloed, highly specialized databases, and thought more of our researchers as working in a broader information space. If you can hit the next slide. So this is sort of thinking from the researcher point of view. We're assuming that they're using things like Google Scholar, our local library catalogs, and then these discovery services that, depending on which library you might be affiliated with, or if you're affiliated with any library, thinking about that. So if we go back now, we can see the whole kind of the great big picture, which is the overall system, which hopefully now looks a little less complicated, and showing this kind of passing from publisher, aggregator, discovery to what the library needs to do, what the researcher would do, and a kind of preservation layer. And as I said, it's really thinking about putting the information where we think our researchers are likely going to be. And if you hit the next slide, and then the kind of closing point that we'd like to make is to also kind of how do you test your assumptions about how people will discover your content. And so we're using Google Analytics to kind of track where our users are coming from, and then we can this is a way of getting feedback and a way to kind of test our assumptions about discovery and think about other strategies as they might evolve. I will add, and Charles is actually quite active in a project thinking about how do you get good usage data from publications that you provide to aggregators, and then they in turn provide those objects out to the world, and so you don't have a really good view into how the information is being used or how it's being accessed, because you're then dealing with multiple vendors who may or may not have common formats for sharing usage data. And so I guess part of the point here is to just reinforce that having theories of discovery and then looking at the usage data is really important to be able to test and change in order to make sure that you're actually reaching the needs of your researchers. So that's sort of what we had to provide. Charles, I don't know if you want to correct any of the things that I got wrong in my part of my presentation.
No, thank you. That was great.
Thank you both. That was very interesting. I realized during the presentation that I managed to mispronounce both of Mike's affiliations. So sorry about that. Yeah, is there any comment or question to our two presenters right now?
So Peter Murray Rust here. A wonderful subject to be talking about. It's much more complex than scientific journal articles and so on, because you've got a whole spectrum. Do you go anywhere into the undergraduate area? Because this is one of the big political problems where publishers charge huge amounts and have monopolies and so on. And the open educational resources and so on is making, I would say, slow headway in this sort of area. Or are you always selling directly into actual PhD students and higher?
So Peter, thank you for the question. I work at an undergraduate institution, and so we like to think of our undergraduates as researchers too. So when I say research, yeah. Right. So and really some of the genesis of this particular Lever Press project came from our deep frustration and dissatisfaction with the status quo and having to deal with monopolistic practices and unreasonable price increases year over year. And so very much thinking about how do we meet the needs of undergraduates, but also provide outlets for faculty and other researchers. And we didn't talk as much in our presentation about Fulcrum and Lever, but it's also of great interest, the kind of born digital affordances that a platform like Fulcrum allows, and allowing for the integration of media and data into monographic work.
Well, I've got a lot more questions if nobody else has, your infrastructure is very complex. You've got various gatekeepers in there like OCLC and ProQuest and so on, and all these people work by monopolizing the bibliography and the control of access to information. Do you see any areas where, open book, I have a colleague in Cambridge, I'm sure you know, Rupert Gatti, who does open book publishing. Do you see any areas where, any particular domain areas where open textbooks are, making big inroads?
Yeah, this is Charles, and yes, Rupert is a good collaborator and colleague, and this COPIM project that I mentioned in passing is really important and is being driven by Rupert and some of the other smaller open access book publishers to create an infrastructure that bypasses the main gatekeepers. I mean, I think there's room to work within the gatekeeping structure as well as outside it, but certainly that combination of strategies really helps. In terms of books that really are working for broader audiences, including undergraduates, books are in the space of advocacy, environmental advocacy, climate change, as you've talked around, Peter, and some of those broader topics that really become useful for advocates in various public policy situations, as well as for students, seem to be doing extremely well in the open access space.
Excellent.
All right. So if there are no other questions or comments at this point, thank you very much for your very interesting presentation and also for covering this sort of parts that we hadn't covered before. And so we're now at the 2-hour mark, and we wanted to have a discussion at this point, but I think we had the discussion as we went along. I wanted to leave you with a few closing thoughts, just a few minutes to sum it up a bit. So I think what we've seen are great examples of the open discovery infrastructure today, of what it can do, and the big potential that we have going forward, really overcoming this discoverability crisis. But I'd like to remind you that not everyone agrees that this is the best way moving forward. And one of the other visions for the future is coming from Elsevier. And this is an image that they published about 1.5 years ago, and it is the information system supporting research going forward in their view. And from a first look at it, it doesn't look too bad. You have got actors from the open discovery infrastructure like PubMed or arXiv or OpenAIRE. So maybe we're not that far off from each other. But the problem is, and I'd like to thank Björn Brems, who first pointed this out on Twitter, is that everything within these boundaries is actually an Elsevier product. So everything that relates to the open discovery infrastructure is pushed to the side, and we're more or less nice data providers to them. And in the center of this image, of course, is the user. So everything that a user interacts with is an Elsevier product. And you can, if you take a closer look at this, see that many of these are actually discovery products or products that have a strong discovery element. And this creates a black hole, I would say a black hole of dark knowledge, because it sucks everything in. It sucks in the control about how we deal with our user data, the control over algorithms, the control over how researchers interact with open science. It also takes away the governance that we're talking about so much in the open discovery infrastructure. In here, we don't have a say. And finally, these are all one-stop shop turnkey solutions. So you can install them, but once you install them, you will not be able to get rid of them anymore. You're essentially locked into them. And this takes away all the innovation because you only have a few people, a few organizations that dominate the market. And it also sucks in all the funding. So this is something that we've seen with publishing, and it's certainly also a threat that this is going to happen with infrastructure. And if you look around the open discovery infrastructure, you will see that most of the initiatives are completely underfunded. Services that we rely on every day, they have maybe 2 or 3 full-time equivalents to do all the work. It relies heavily on volunteers. And I'm not saying that volunteering is a bad thing, but it should be something that's optional, not that's mandatory for an infrastructure to run. And so I think going forward, we simply cannot leave it to these big proprietary vendors to take us out of the discoverability crisis, because essentially one of the reasons we're in this mess is because of them. And so we have to make the open infrastructure sustainable. There's no way around it if we want to get out of the discoverability crisis. And how to do that, of course, is a big open question. But thankfully, there are a number of initiatives that are taking a look at this, and I encourage you to look into them. So we have the 2.5% commitment. This is an interesting article by David Lewis, where he argues that every library should essentially set aside 2.5% of their budget for open infrastructures. Then we have SCOSS, the Global Sustainability Coalition for Open Science Services, and they put this idea more or less into a crowdfunding model where they recommend every year a handful of organizations, infrastructures for funding by libraries and library consortia. And then we also have Invest in Open Infrastructure, and they are more of a new initiative, but they're looking at this from a global and a comprehensive scale. And if you go to their website, you can sign a statement of support, and you can also take part in their survey that they're currently running. So if you're in open infrastructure, I encourage you to go there and do that. With that, I would like to thank you for your attention. Thank you for staying with us for quite a long time today. You can contact us on our websites and on Twitter, and also via email. So thank you very much. Stay healthy, stay safe, and I'm looking forward to continuing this discussion with you at another point.